The short video will take you through the answers to the multiple choice of the grade 12 chemistry exam paper written in June 2014 at Pinelands High School. Question 1.1. Which of the following compounds below is a ketone? I think the only way to answer a question like this is to just draw out each structure. So let's go with the first one, CH3, and then there's our C double bond O single bond H. There's a functional group, and that's an aldehyde, so that's not the correct answer. The next one, CH3, C double bond O, single bond O, CH3. So that clearly shows the ester group. Again, can't be the correct answer. Let's have a look at C, CH3, CO, CH3. So there we have the ketone group. So it looks like C is the correct answer. Ketone is what we're looking for, and C shows us that ketone group. Let's just check on D, CH3, CH2OH. And that's clearly the alcohol group. So C is the correct answer. 1.2, methyl methanoate and ethanoic acid are isomers. They're best described as. So they're asking you which kind of isomer these two are. Once again, I think the only way to answer it is to draw the two out. So there's methyl methanoate, and its empirical formula is C2H4O2. Ethanoic acid would be CH3, C double bond O, single bond OH, and its empirical formula C2H4O2. So clearly they are esters because they've got the same empirical formula but different structural formulas, and they're the two different functional groups. The one is the ester functional group, and the other is a carboxylic acid functional group. And so these two isomers are functional group isomers. Okay, here's a small section of polymer chain, PVC, polyvinyl chloride, and the question asks for the monomer. And the way to do these questions is to find the smallest repeating unit that makes up that monomer. And so the smallest repeating unit would be a 2-carbon chain with a chlorine attached to the one carbon and then hydrogens to the other. Now I'm going to redraw the monomer out of that. Remember that this would have been formed as a result of an addition polymerization, and so there would need to be a double bond between the two carbons, and so that means that the name of the monomer is chloroethene. Right, an energy profile group, energy profile graph with some questions. Remember, an energy profile graph will plot energy on the y-axis against the course of reactional profile on the x-axis. And the question asks us for which statement is incorrect. So be careful of these questions. 3 of them will be correct, obviously, and you're looking for the one that's not correct. First one states that the forward reaction is endothermic. Well, let's have a look on the graph. That's where we start, and that's where we finish. And so the energy shown by the arrow Y has increased. It's taken in energy, and so that is indeed a correct statement. Let's look at B. It says arrow Y indicates delta H for the forward reaction. We've just seen that that is indeed the case. So Y does show delta H, so that's correct. C, arrow X indicates activation energy for the reverse. Remember, activation energy is from where you start. Remember, we're going in the reverse direction now to where you finish. So that arrow I've drawn in red there is the correct activation energy for the reverse reaction, which means that, so that's EA for the reverse reaction. What it means is that that statement C is incorrect, so that seems to be the one that we should show. Let's just check D. The delta H for the reverse reaction is less than 0, and there you can see on the graph delta H for the reverse reaction goes down, so is indeed less than 0. So that one's correct, which means that C is the correct answer. All right, 1.5. We've got curves showing the decomposition obtained by plotting volume of oxygen against time for the decomposition of hydrogen peroxide. Remember the chemical formula for hydrogen peroxide, H2O2, and it decomposes to form water and oxygen, and this graph shows the volume of oxygen formed. All right, let's have a look at the two graphs. Graph X starts with a steeper slope, Remember, the gradient of a rate volume against time graph gives us the rate of reaction. So curve X shows quite a fast initial rate, and then it flattens out to give you a certain amount of oxygen formed. Graph Y has a flatter gradient, and so that indicates a slower rate, but notice that we end up forming more oxygen at the end of the reaction. Okay, so more O2 is formed in reaction Y than was formed in reaction X. So, which options will give us that? What we're needing is something that will have a slower rate initially, but form more oxygen. If we add water, that will dilute the solution and have a slower rate. So that part's correct, but it won't form more oxygen. So that's not right. Right, option B, adding some 0.1 mol per decimeter cubed hydrogen peroxide. Notice the original peroxide is 1 mol per decimeter cube. So we're adding a less concentrated solution, which will slow the rate down. But because there's more hydrogen peroxide, we will end up getting slightly more oxygen. So that looks like it's quite a good option. Let's have a look at C. Less manganese oxide, that will have a slow rate but won't give us more oxygen, and a lower temperature, again slow rate but no more oxygen. So D is not correct, which means that our answer of B was the correct one. Right, 1.6, we've got an equilibrium reaction. Delta H is less than 0, so forward reaction is exothermic and reverse reaction is endothermic. And the question asks for how we can increase the concentration of CO3 2- ions. Alright, first one, increase the temperature. That will favour the endothermic reaction, which is the reverse reaction, so that's not correct. Increase the pressure. Well, let's have a look. We've got 1 mole of gas on the left and no moles of gas on the right. So increasing the pressure will favour the forward reaction to decrease the pressure, and that will give us more CO3 2-, so that looks like a good option. Let's check the other two. If we decrease the concentration of OH- ions, we will favour the reverse reaction, so that's not a good one. If we add a catalyst, that has no effect on equilibrium, so that's not correct, which leaves us with B as our correct answer. All right, 1.7, NPK fertilizer, 5 to 8. Remember, they are listed in order, N, P, and K, and they're interested. The question's interested in the mass of potassium, so that's the 8. So the calculation looks like this. You take the 8 for potassium and divide it by the sum of those numbers, so 5 plus 2 is 7, plus 8 is 15. So 8/15ths of it is potassium, but only 42% is made up of active ingredients, so you multiply it by 42, and then we've got a 2 kilogram bag, so you times it by 2 kilograms, and that gives us 0.448 kilograms, or obviously 448 grams, and so correct answer is C. Alright, acid-base reaction, again asking which statement is incorrect. A, NH3 and NH4 plus form a conjugate acid-base pair. That's correct. They differ by an H plus. NH3 acts as a base. That's correct because it's accepting a proton. C, H3O plus and H2O form an acid-base pair. Again, they differ by a proton. So that looks like it's correct. And the last one, H2O acts as an acid. Well, in the reverse reaction, H2O accepts a proton, and therefore it's actually acting as a base. So that's the incorrect statement, and so D is the one. All right, 1.9, ammonium chloride's pH when dissolved in water. Ammonium chloride is formed by the reaction of ammonia plus hydrochloric acid to give us ammonium chloride. Ammonia is a weak base, hydrochloric acid is a strong acid, and so ammonium chloride will be an acidic salt, and that means its pH is less than 7, and so the correct answer will be B. And then finally, best description of ethanoic acid of 6 mol per decimeter cubed concentration. Well, we know that ethanoic acid is a weak acid, and we know the concentration of 6 molar is a concentrated concentration, and so we have a concentrated weak acid, which means D is the correct answer.